going to bring on our moderator for the panel, Tom Zuber, who is the managing partner at Zuber Lawler. Tom, how are we doing? Good afternoon.
Good to see you, Spencer. Thank you. Great to be here at Benzinga again. Great affection for everyone over there.
Great to have you on. I'm going to let you introduce your panelists for this panel on emerging innovations and the companies behind them. Take it away.
Great. So I'm Tom Zuber. I'm the managing partner of Zuber Lawler. And under God, we have 7 offices across the country, including in Los Angeles at our headquarters where I sit. We represent a long list of Fortune clients, including energy Fortune clients. And we've been doing that work for over a decade in the areas of high-end deals, M&A, finance, so forth, IP, regulatory work, and lots of litigation. And we do a lot of international work under our Zuber Lawler global banner. We're also a technology-focused law firm, so a bunch of bioscience nerds, I guess, on the attorney roster is the best way to summarize that. Next, I'll go ahead and just go around my Zoom screen here, my video screen here, and allow my panelists to introduce themselves. So I'm very excited about this panel. We have 2 outstanding executives, very exciting companies, and even more exciting technology, if I might say that. So we'll start with Stephen Rossi, CEO over at Worksport. Stephen, you want to tell us a bit about yourself and your company, please?
Sure, yeah. Very nice to be here. Welcome, everyone. Thanks for joining us. I'm the president and founder of Worksport on the OTC WKSP. We produce truck gear for the pickup truck market. More interestingly, we produce solar micro generation systems, turning these pickup trucks into microgrids and battery systems for portable power for campers, contractors in the event of natural disasters.
Thank you, Stephen. And Dennis Calvert from BioLargo. Can you tell us a bit about yourself, Dennis, and also your great company?
Yeah, of course, Tom. Thanks for being here. This is great. Yeah, so BioLargo, right? Our slogan is we make life better. We're focused on clean air, clean water, a cleaner earth. We've been developing technology platforms. We've got multiple for about a decade. We also have a full service engineering group. So supercharged with science and engineering experts that solve some of the biggest problems that we face around the world. And one of our emerging technologies just now going commercial is focused on PFAS. We'll talk about it, PFAS. That's these forever chemicals stuck all over the world. Anyway, we're really an innovator, become solution provider, and then leveraging through this technical innovation. So it's really a symbol BLGO. So there you go.
Great. So let's just dive into it. Dennis, why don't we stay with you then?
Sure.
On the notion of PFAS, can you tell us a bit more? I'm familiar with it, and of course, the forever chemical NOMER. Can you go ahead and tell our audience what is PFAS and how does the PFAS contamination issue feed into such an urgent conversation for everyone?
It is an urgent conversation. Excellent, Tom. Thank you. So PFAS, per and polyfluoroalkyl substances. It really references the class of chemicals that were used to make nonstick coatings. Been around for about 30 years. When you read about it, if you do an internet search, you'll see some of the big names like DuPont and 3M have come under extreme pressure, regulatory pressure, legal pressure. These chemicals were used to make nonstick coatings, right? They went in food, they went in food packaging, they were put in coatings, metal coatings, I mean, on and on and on. And the movie Dark Waters really sort of brought PFAS to the public awareness about 2 years ago. And then there's been this continual attention, extreme focus, because PFAS, if you think about it for just a second, a little bitty compound measured in parts per trillion that you put out a little bit every day for 28 years, and nature won't break it down, right? That's what we're talking about. Chemical compound that nature will not degrade. It's actually designed not to degrade. It's the point of the invention, right? Non-stick coating. So what happens is a little bit for 20-something years, and you got a big problem. So it's been linked to adverse health effects. If you again, internet search, you're going to see tons of material. But what's happened is because of the increased ability to measure these compounds and the link to adverse health effects like cancer, of course, and birth defects, and some really significant health threats, especially in concentration. There's an outcry around the world, especially in industrialized nations. So the Biden administration, a couple of days into office, made a pronouncement that PFAS was one of the key environmental concerns for the decade. In fact, people call it the compound of the decade. And so we got a little bit of a head start, which is really important because, as you can imagine, as these emerging contaminants come to bear, you got to be ready. And so this is a very special compound. We have to do something special to tackle it. And so we've had about a 2-year jump to be prepared, and we're just now going into commercial trials with some of the leading customers and partners in the world. And we got about 2 years of development work under our belt, so we're really locked and loaded, as they say. So there you go. That's great, Dennis. And Dennis, why don't you tell us while you're at it about BioLargo's PFAS extraction technology? How does it work? Why is it so effective? Yeah, so the state of the art, really, the incumbents, if you will, the old technologies that have been around for a long time is carbon. So just remember what carbon is. Carbon, activated carbon, charged carbon, right? That's what we're talking about. That's the incumbent. The way that works is through a principle called adsorption. So as water flows through a carbon media, the pluses and the minuses attract, they bind to the surface. And as you can imagine, a carbon system will extract everything. That's the key, right? So when we looked at this problem, we said, the problem with that is if you're doing groundwater, for example, like well water to make drinking water, that's what we're talking about. Yeah. That water's got a lot of stuff in it. And if you're going to use carbon, it's going to get everything. And so all of a sudden, in order to get this little compound measured in like 60 and 70 parts per trillion, you're having to treat the entire body of water and take all the stuff out of it to get that little compound, which is minuscule. And so what we did is our engineers, frankly, not me, our engineers said, we got some ideas. I got a call one day from our lead engineer, Randy Moore, and he said, I think we got an idea that might just work. I said, yeah. He said, I'm going to need a little budget. He said, I want to go do a little proof of claim, which is really like a little science experiment. And the theory of that was that these PFAS compounds have a charge, and they tend to act like an ion, a salt, okay? And with a charge, you can affect its mobility, right? Real simple concept. If it's charged, you create an electromagnetic field. You can pull it, you can direct it, you can move it. So basically, they built an electrolytic cell, and there was a bunch of theories about how it was going to work, and how it actually worked when we were done was that we put a membrane through a chamber, and as the water flows through the chamber, across the membrane, not through the membrane, very important, across the membrane, it tends to act like flypaper. It's the best analogy I can give you. And so as the water flows across, the PFAS is directed. As it hits the membrane, it sticks. And it sticks like glue. It doesn't come off. And so then you can recycle, you can scale up, and basically you're talking about electrolytic cells that flow the water across, migrate the PFAS, and then selectively extract. That's the key, selectively extract. So what happens is when you're done, we end up with a 55-gallon container of waste versus truckloads of carbon. So you talk about sustainable footprint. I mean, this is the cutting edge, And so what we've proven is it does work, it's viable. And then this morning we did a press release announcing that we've had a technical breakthrough confirmation of extended functional life of the membrane. It's a big deal because you can imagine you got electrodes, you got to flow water, you got some parts that are going to fill up with this contaminant that become a recurring revenue opportunity to collect and dispose of and replace for your clients. And then the thing I'd point out from a business perspective is this is estimated to be about a $3 billion a year problem in the United States alone. It is global. Any industrialized nation is dealing with PFAS. Europe is catching on really quick. There's been all kinds of mandates to remove it. And these projects will range in the low end of probably $250,000 all the way up to $30 million each. And, in our local market, the Orange County Water District has tested about 40 of their wells have tested positive for PFAS. And when that happens, they turn off the well. They can't serve PFAS contaminated water to the public. It doesn't work. It's not feasible. And so what happens is those wells, especially in a drought-ridden state like California, they have to treat the well. Well, they're estimating the cost to treat those 40 wells at $1.5 billion. I mean, wow. I always say, in my backyard, 30 minutes from my office, there's about $1 billion worth of business. So, I mean, and again, we won't get all that, right? We're the small guy with this great innovation. So what we're doing is we're advancing the state-of-the-art science and technology for engineering. And then we partner, right? We end up working with engineering firms all over the world to see this product go to the market.
Dennis, absolutely fascinating. And I think if you can make a living while you're saving the planet, all the better. So you've mentioned one big advantage of your technology, which is obviously the manageability of the waste, the byproduct, right? So that's obviously huge. No further explanation needed on that. How about in terms of efficiency, in terms of time per volume, right? So
So we get a single pass, right? So that's the beauty of the system. You get a single pass, you're getting over 99% extraction. right? And then by virtue of the way the system works, you can actually take that extra 1%, which now again is measured in the parts per trillion, 60 parts per trillion. Okay, so parts per trillion, that's like a grain of sand in a swimming pool. I mean, you got to really get perspective here, okay? You're after a contaminant that is so minuscule. So that's the trick. You can get it out, you can concentrate it, isolate it, and then dispose of it properly. Well, so the key for us, I mean, if you look at the regs, what you're going to find is the government's going to control what happens to the waste product. Are you going to incinerate it? You're going to contain it? You're going to degrade it? You're going to use enzymes and eat it? What are you going to do, right? There's all sorts of solutions about the destruction capability. And we're working on some of that too, by the way. But our strategy at first was isolate and collect, and you've got this extraordinary efficiency, right? So we think we'll compete head on with CapEx, but we're going to be 1/20th the cost of an OpEx. I mean, it's a pretty dramatic cost comparison, especially when you think about the cost to manage the disposal product itself. And listen, there's already regulations saying in around the country by the EPA that says we're not going to burn carbon-laden PFAS in our community. Well, now what are you going to do with that carbon? Oh, you're going to landfill it? Oh, guess what? That stuff's coming back. It's not going to go away. So this is a significant issue because the compound was designed to not break down. So there you go.
Great stuff, Dennis. Really, I applaud your efforts and the effect it has on the environment.
It's like a 20-year overnight success. It's awesome.
Those are the best.
Okay, great.
Overnight successes that you build over 20 years. We have another panelist, a guest, Ryan Melser. Welcome, Ryan. And why don't you go ahead and take a few minutes here to tell us about yourself and also about American Battery Technology and the exciting things you're doing there.
Great. Thank you, Tom. Good to be here. So at American Battery Technology Company, we have two parallel businesses. We have developed a first-of-kind integrated system for the recycling of lithium-ion batteries, where we're able to take in full packs and modules from electric vehicles or stationary storage systems or consumer electronics, and in a very high speed and automated fashion to separate those packs to modules to cell subcomponents and then to sort those components in a matter of minutes. So we're able to do that in an automated fashion with very minimal direct labor, and we're able to do it while the material is still electrically charged, so not needing that very slow discharging period to begin with. Once we have them separated, we're able to sell many of the lower value scrap metals, and then for each of the high value battery metals, we've developed our own chemical extraction train, where we can extract one of those metals at a time, purify them even past industrial grade, up to battery grade quality, and then we've been working with some of the very large cathode companies in the world to sell these battery metals directly back to them, which they then make into new cathode material to go back into new cells, to go back into the market. So we're enabling a closed loop economy by closing the chain on these battery metals. And separate from our recycling business, we also work in primary metal extraction. So working with ore and brine resources throughout the US, and have developed new methods of, again, extracting individual battery metals. So we've been starting off with different lithium resources we're using to extract from, and also doing some development on cobalt and nickel bearing resources. And again, these primary metals we're able to extract to purify to battery cathode grade and then to sell into the market. So while the occupied mass of electric vehicles keeps growing on the road, recycling is very important, but even 100% recycling can't make up demand because we keep adding more material to this closed loop. So it's important that we have both our recycling system and our primary extraction systems to really satisfy the needs of this rapidly growing market.
Thank you, Ryan. Very exciting technology, and I think it's quite interesting having both you and Stephen here, and we'll dive into why I think that's the case in a moment. So Ryan, we'll come back to you. I want to return now to Stephen Rossi. Stephen, your technology is very exciting from a different standpoint, and I personally, as an electric vehicle owner, I own a Tesla. I think what you're doing really makes a whole lot of sense here. Of course, electric energy is cleaner, no doubt about that. But oftentimes, the source of the energy, and I think Ryan speaks to this, is dirty, right? The source of the electric energy, that clean electric energy, can be dirty. So there's that aspect to today's I guess you could say, mechanisms for delivering renewable energies to the populace. And then on the second end of things, of course, on the other end, can we sort of reduce the need for sources of electric energy that bear a carbon footprint with those with sources that don't bear a carbon footprint? And so you get into that, and I find it to be very fascinating. So I don't want to steal your technology. Can you tell us a bit more, Stephen, about your renewable energy technology and how it works and what it means for the electric vehicle marketplace?
Sure, absolutely. Well, that is Terravis by Worksport. The Terravis has been something we've been working on since 2014. So we kind of started it when we were a little crazy, I guess, to think that far in advance. But our mandate is you don't have to always be the best, which we are, but you should be the first, which we are as well. Yeah. And part of that mandate was to anticipate the forthcoming electric vehicles with the Terravis. So to define the Terravis, and I think we might be able to show the Terravis in action, is it's a fully functioning truck accessory that is made using, at this time, monocrystalline, but we're exploring amorphous and different perovskite type solar generation stations. So it uses solar panels as part of its composition, and it provides 30 to 40, well, let's say 30% of the average American's daily commute. So the average commute is about 30 to 35 miles. It'll charge about 10 of those miles out of the gate as the first rendition, and we will look to develop that technology further. So part of our internal mandate was to really question, is EV green? And there's been at length discussions on how much greener are they to produce. So what carbon footprint, as Ryan may understand, is there in producing the power, the lithium ion or lithium iron phosphate battery technologies that power these vehicles? And then where is the power coming from? And one of the analysis we've done is that the depletion or the reliance of homes on natural gas is depleted far faster because of perhaps global warming than would have otherwise been anticipated. So now there's this great supply in this natural gas system looking to find an avenue to generate revenues. And we're discovering that a lot of the need for more energy in the grid is being answered by popping up more natural gas power plants. So the ultimate problem is, are we merely deferring the exhaust from the tailpipe of a gasoline or internal combustion engine vehicle to that of a greater smokestack of a natural gas, coal, or oil producing power plant? We all know that hydro and nuclear energy sites are fairly hard to commission and then decommission or service. So the Terravis looks to answer that. As pickup trucks are becoming more mainstay, with a third or better of the population already in the U.S. driving pickup trucks, 65 million of them, if we can start by providing 30% of the power that they need in our first rendition of this product, what will that look like in a year when we really innovate, or in 2 or 3 or beyond as we move into different types of solar? So the Terravis will recharge electric trucks. It will also turn current internal combustion engine trucks into 60 million microgrids traveling the U.S. So they're power for campsites, power for job sites, and power in the event of a natural disaster like we saw in this winter past in the U.S. Moving beyond that, we're focusing on the core battery system as a freestanding product. So if you don't have a pickup truck and you don't have an electric pickup truck, you could buy our core battery system. And the core battery system's got a hell of a lot of innovation behind it to be used as a mobile battery pack for, again, the campsite, job site, or in the event of a natural disaster. So we've identified, nonviolent military applications, disaster relief, and medical applications that are innovations. And I could speak more to the innovation within the technology of the battery pack later. But we're really building out the mobile power microgrid systems, as well as a meaningful charge for the forthcoming Lordstowns, Rivians, Teslas, Hyundais, Fords, GM and Hummers, Atlases, the Hercules, and the nameplates just keep going. So we believe that the Terravis will be a very meaningful source of energy for the trucks, and will become much more meaningful as we really start to innovate. And that, in essence, is the definition of Terravis and its mandate and the problem it's anticipatorily solving.
Great. Stephen, you got into some of this just now, but I want to flesh into it a bit. And of course, I understand the answers here, but for the sake of the audience, does one size fit each flatbed? And I think I just heard the answer, but for the sake of the audience, could you elaborate on, does one size fit all flatbeds? And then what other types of cars can use this technology today? So you've obviously developed that for flatbeds already. Have you already developed it for other types of cars besides flatbeds? And if not, what's the time frame on that? So again, starting first with, does one size fit all flatbeds?
Yeah, so our battery system, and so the battery system is a one battery system for all. It's a modular battery system. But in terms of the cover itself, the solar panel array, it's a bespoke design. So we would have a different SKU for different trucks. For example, the Rivian RT1 would have a 5-foot bed, and that design would be unique. So it'd be a uniquely designed product to connect within those trucks as either an OE or an aftermarket accessory. And we have anticipated many years ago implementing universal microgrid systems by means of universal mounting and folding solar arrays pairing with our modular battery system. And those can be deployed for marine applications, for intermodal like freight and transport, for well, I said intermodal already, so even like containers and trains, to microgrid systems for campsites, bunkies, cabanas, and for any needs you want. So we will end up delving more into universal microgrid systems beyond that of just for pickup truck markets. And another anticipation that we're going to be launching next year that's very exciting for us is micro charging stations. So for fairs and events and concerts, when things become back more normal, as opposed to establishing the Burning Man event with thousands of liters of fuel and generators, the TerraV system could be microgrid systems to power those large outdoor events using clean green energy. And we could our capacity would be to sell the systems as well as lease and deploy the systems in events or natural disasters. So we would maintain inventory across the globe of our charging stations and our microgrid stations to deploy when really needed on a residual income platform.
That's great, Stephen. One more quick question here before I go on to Ryan. And as I explained to my panelists backstage, everyone, given the nature of this discussion, emerging innovations, we wanted to spend a bit more time with each panelist rather than jumping around between panelists as I usually like to do. So Stephen, sticking with you for one more quick minute here. I think the notion of knocking off a third of your energy spend, so to speak, per day is already a material, meaningful, a pretty extraordinary impact. Can you tell me, though, do you think that we'll ever be able to eliminate the need to plug in your vehicle at all? Will we ever have enough energy captured by something sitting on top of your car that you could avoid that altogether? And if so, how long does it take you to get there?
That's an interesting, it's forward reaching. We'd like to believe that it would be more possible as communities maybe become more compact and people need to travel less. I think that longer travel, I think that would be further reaching to think that we could charge using solar. But Worksport's anticipating charge stations and their parasitic nature in having to be tied to a huge amount of power on grid. So I guess my answer would be a few, multi-part. Number one is I believe that solar, if you do a case study back on when the White House first put solar on it, those panels were just over, I think, 10 or 12% efficient. In a few decades of solar innovation, and the innovation is speeding up. So 1 year of innovation today is like 5 years, 10, 20 years ago. Looking at solar efficiencies over the years, and with so many different hybrid solar technologies like a Morpheus, perovskite, an HGT, I think that we will only improve we will only become more meaningful in the amount of power we can generate. So we will go from 30 to 40 to 50% indeed, but Worksport's already anticipating the parasitic charging stations in, again, these Tesla superchargers needing massive amounts of powers in cases. For Worksport to launch in the future TerraV Energy, which would be non-parasitic charging stations that get their power through other forms of renewable energy and not through grid power. So that even when you do charge, you're not getting your power on the other side of the cable from a coal, oil, or natural gas plant, but from a clean green technology. And we're heading that up, and we'll be making some really exciting headway in that market and those fields in the.
I think we lost Stephen for a moment there, but I think we all got the gist of that. Great. Thank you, Stephen. We lost you for a moment there, but we got
Sorry, guys.
That for a couple seconds. It's really fascinating stuff. So thank you very much for that, Stephen, and congratulations on that technology. I want to now, Ryan, return to you, and if we could take a bit of a deeper dive into your technology and what you've accomplished over there at American Battery. First, you've told us a bit about American Battery's technology already. Can you tell us a bit more about, as I understand it, there are two aspects, to oversimplify things dramatically, two aspects to your technology in a big picture sense. One is the renewable, the recycling aspect of your technology, which is on obviously the far side of the process where you're finished with the battery and what happens to the battery after that. But you've also got something at the beginning of the process, which is the extraction process itself for extracting lithium from the environment around us. I'd like to know a bit more about each of those technologies and how they relate. So starting first with the recycling technology, can you tell us what makes American Battery's technology different from the processes that are out there already that relate to recycling?
Yes, of course. And like you mentioned, there's the beginning of a process, usually there's the end of a process, but because we're creating a closed loop economy, we end up on both sides of it. So we are receiving the end-of-life material, and we are producing the new battery metals that go back into new battery cells themselves. So it doesn't end up being a beginning and an end. This really just closes the loop to make these battery metals be used indefinitely. On the recycling front, what we really do differently is many processes today really just use what were designed to be, scrap metal and stainless steel recycling systems. They start off with, very high temperature melting furnaces where they simply melt all the material together. And when you have aluminum or scrap metal, that works rather well. But when you mix batteries in, there are many elemental materials within a battery cell that become very toxic when they're taken at high temperature like that, such as fluorine and phosphorus and sulfur elements really get turned into this toxic air emission. You get particulates of heavy metals that are released in the air as well, and many of those materials end up going in large amounts of water emissions. So you either have to allow those materials to go out as contaminants, or you need to spend on costly systems to then have them removed again from the air and water emissions. And when you do that, there are high value materials in batteries like cobalt and nickel and lithium, but there are many low value materials like iron and aluminum and mixed plastics. And when you simply melt everything together, it then makes it very difficult to separate out the high value from the low value materials. So it really hurts your recovery efficiency. It results in a much larger environmental impact, and it's more costly. So again, my background and much of the team I brought on here the past year, we were some of the initial designers of, the largest battery factory in the world, the Tesla Gigafactory outside of Reno. So we started back in early 2015 and really started when that factory was a patch of dirt out in the desert. And we're part of every part of the design of that facility, the startup of the systems, the commissioning, and the troubleshooting of many of those production lines. And really from learning how batteries are made from a fundamental manufacturing side, how they go from powders to slurries to coated electrodes to dry and press systems to rolls to cells to modules to packs. So instead of actually just melting everything together, we've used that skill set to design what we call a demanufacturing process, where we essentially back out each of those operations in a very automated and high-speed fashion that allows us to get back to separated metals and powders within a matter of minutes without a large amount of labor, and while really preserving the separation of those high and low value materials. And then once we have that high value powder separated out from the rest of the low value materials, that's where we use a custom chemical extraction train that we've developed. And these types of chemical extraction processes can also have large environmental impacts if not done correctly. They can consume large amounts of acids and bases, use very large amounts of solvents and oxidizers. And by removing so many of those low-value materials upfront mechanically, we're able to use a much more targeted and simpler chemical extraction train for these high-value materials. We've also developed a system where we can actually generate our own acid and base and reagents on site ourselves instead of buying from the open market, where again, those second and third tier emissions are very large for how acids and bases are manufactured today. So by having this automated high-speed system at the front end, where we have absolutely no high temperature operations, even our process heat and our space heat is generated by waste heat recovery and electric heat pumps. We have no combustion anywhere on site. We have near zero air emissions. We've developed a closed loop water system, so no hazardous liquid water discharge. And by upgrading these materials all the way to these rigorous battery cathode quality, every time we sell a recycled battery metal to the market, it displaces the mining of a primary material. And some of the most polluted places in the world are nickel and copper mines. And every time, again, we go through this recycling process, much of our environmental benefit is displacing the need for those very polluting technologies.
Very good, Ryan. Thank you for that. Fascinating and I think vital technology. I'd like to return to Dennis if I can. Dennis, what's BioLargo's path to material revenues, and how far away is BioLargo from material revenues?
Yeah, so we're breaking revenue records already, which is good. We've got multiple assets in the portfolio. We have an odor and VOC product, which has been deployed about 6 years. We clicked off about $2.5 million in revenue last year, which we think is still scratching the surface, right? It's not anywhere what we think it's going to be. But in the portfolio, we have multiple assets coming to bear that are all actually significant. The average ticket is what's happening. We've gone from $50,000 and $100,000 projects that now can move into the $250,000 to $1 million to $3 million projects, right? So that just the ability to have critical mass and raise up that way is significant. The other, of course, is this PFAS solution really represents 3 revenue components. There's a design component, which is engineering. Then there's a construction component, which actually installs these systems on site where you're going to treat infected soil or infected water, like Air Force bases. We're already under contract with the United States Air Force as air quality suppliers. And then there's water treatment, right, where these systems are going to be installed. Anyway, those projects will range at the low end of about $250,000 to the high end is up as high as $30 million. I mean, this is pretty big business. Yeah. And so think about a $30 million project. That means there's a building that was built alongside a well that feeds drinking water to a city. That's what we're talking about. This is a significant installation. So for our company, right, we present this technical excellence for air, water, and earth. And we present an engineered design, which is now patent protected by patent applications in process, brand new innovations, proof of claim, a lot of art. And now we come to the market and we say, look, we can design, we can construct, we can install, we can service and maintenance. But the reality is to really get big, we're going to need to partner with people that serve those clients already and want to fix this problem. So that's probably big engineering, right? Because if you go to any of these major waterworks, you're going to see a big engineering firm on contract. Those are going to end up being our partners because that's really how you get to scale. And again, with a global market and what we believe could be the sort of franchise player as the leading innovation in this space for this problem, there's no reason we couldn't see dramatic revenue growth in really near term. Now, we'll be in the field probably in the next 60 to 90 days with 2 of the most significant flagship clients in the world, federal government being one and a major water district being number 2. We're already approved vendors in the system. We're now just really refining the detail of what the trial actually is going to look like. And I always say internally, if we put out the word that says, okay, we're in business, ready to roll, we could get 100 trials. There's more business for this problem than we can possibly meet the need for. So we got to prove it up, show the economic validation. Really, it's an economic validation. How long will it last? What does it take to service it? We already know it works. We already know it's scalable. But we need to show it in the field to scale and then start partnering with these big engineering firms and get it out to market. So that's our strategy.
Wonderful, Dennis. Congratulations on the progress, and it sounds like there's a lot of progress in front of you. Spencer, do I have time for one more question here?
Yeah, go ahead. We got a couple questions from our chat. We're running over, but that's all right. Go ahead, Tom.
So one question I have for Stephen. Stephen, how close are you to having a commercial product that you can ship in quantity?
Terravis, the core system's coming out first. We're in pre-production prototyping now. We have to go to IPCJ standard testing. So we're expecting by Q3, Terravis solar cover pre-launch and pre-launch website coming soon. We expect these covers to be on trucks this year. Full commercial scale launch. Will pair nicely with forthcoming EVs and the launch of like the Rivians and the Lordstown in early 2022.
That's great.
Oops. Yeah,
go ahead, Spencer.
I was going to throw in one from the chat. This is for Ryan. In the extraction sector, how many acres do you actually own and or control? Oh, Ryan's on mute. Oh, there we go.
There we go. Right, so for the recycling side, it's a relatively small facility that's not acreage based. On the primary extraction side, we had about 1,300 claims last year. We've dropped that down to just under 700. And again, that is different types of brine claims as well as surface material. And throughout central Nevada, there are different types of resources we're evaluating right now as well.
All right, I think we're at time, everyone. So, Tom, great job moderating. Liked your approach of spending a lot of time with each company. You can engage with Ryan and Tom and Dennis and Stephen on our virtual networking platform if you're on that. Guys, thank you all so much.
Awesome. Thank you, everyone. Great time. Appreciate it.
Great to be here.
Bye.